Hello everyone, this is lesson 23. This is the last one. Yay! Okay, so this lesson it's about the definition definite integrals. So before we learn about indefinite integral, right? So indefinite integrals. So means that we have just antiderivative. And then we had integral notation. So we don't have anything here, right? And then we want to know about the antiderivative, right? Okay. But then last time, we know how to find area under the rectangles, right? Today, we want to find the area under the curve with just using the antiderivative. We don't do that rectangle anymore, okay? All right. So because mathematicians, they look for always easy way, convenience way, right? So this is a more easier way than we draw the rectangle all the time and we make area of each rectangle, right? That's too much, right? That's a lot of work. So what about this, right? So one of the mathematicians, Riemann, he found out this is the easiest way. Okay, let's take a look. So how do you find the area under the curve? So this one, look, we did not have here, right? But this time we have this one here, means that we want to evaluate the function from A to B, right? So this one is telling us definite integrals. All right, now this one we called lower limit, or some other book indicate the lower bound. And this is the upper limit or upper bound, right? Either way, we can call it. And this is also, we have fundamental theorem of calculus. So how do we use fundamental theorem of calculus? So find antiderivative of f of x. So we say that that is the uppercase of f. Now we want to evaluate the antiderivative at x equal to b. So this one we can express f, the uppercase of f of b. Now, number 3, evaluate the antiderivative at x equal to a means we say the f of a. Then subtract answer 2 to minus answer 3. That means uppercase of f of b minus f of a, right? So uppercase of f means antiderivative of f of x, yeah? All right, so then there will be f of b minus f of b. Yeah, that's how we find any area under the curve, right? Okay, let's do it. So evaluate the definite integral. All right, so first we'll define antiderivative of this function. So let's say that this is f of x. Yeah. By the way, so the f of x is the height, right? Then dx will be width, right? Make sense? That's how we did last time, right? The area which is equal to width times height, right? Okay, so now this is width, right? Antiderivative of x squared, which is x to the third, and then divided by new power, which is 3, and then we want to evaluate from 3 to 5, right? Okay, then we factor out the 1/3, and then let me see. I just make a step 1 and then yeah, just delete them. All right, so subtract f of b minus f of a, so 5 to the third minus f of a, which is 3 to the third. So basically we just substitute, right? Or we can skip, not skip, we can keep the 1/3 inside, that's fine too. Is okay with you? All right. Then the inside we have 98. If we calculate, then we get 32.6667. All right, second one. So we have 3 terms. How do you do? So we split term by term. So there will be integral from 4 to 6 for x to the third power dx minus integral from 4 to 6, 6x squared dx minus integral 4 to 6, 7x dx, right? Okay, now antiderivative, we keep the coefficient, and then we add 1 divided by new power, and then we want to evaluate from 46 minus, we have 6, keep the coefficient, x to the third power over 3, and we want to evaluate from 46 minus last term, we keep the 7, add 1 for the power, and then keep divided by new power, and we want to evaluate from 4 to 6, yeah? Okay, so this is 4 over 4, which is 1. So we have a 6 to the 4 power minus 4 to the 4 power, right? Negative 6 goes twice from the 3. So we have a 2 x to the third. So 6 to the third minus 4 to the third. And minus 7 over 2. 6 to the second power minus 4 to the second power. Is it okay? All right. Then 6 to the fourth power, 1,296 minus 256. And minus 2, 216 minus 64. Minus 7 over 2. 36 minus 16, right? Okay. The first term, we have 1040 minus 2. Second one is 152 minus 7 over 2. 20. Okay, so 1040 minus 304 minus, we can simplify, this is a 10, which is negative 70. Then everything we calculate, then we have a 666. It's okay? All right. This is the one what we did last time with the rectangles, right? Remember? All right, now we want to find the area in the first week, 6 weeks, yeah? So how do we do? So we have the integral from 0 to 6. And we want to make this here, right? Dx. All right. So we want to integrate term by term. So we have from 0 to 6, 0.27x to the second power dx minus from 0 to 6, 9x plus from 0 to 6, 100. Oh, missing dx. Okay, so there will be, we want to make antiderivative, so we keep the coefficient, we add 1 for the power, and then divide by new power. And we want to evaluate from 0 to 6, and 9, we add 1, so x to the second power over 2 from 0 to 6, plus 100x, we evaluate. So 100x over 1. So over 1, we did not write down. So from 0 to 6. Is okay? All right. Let's evaluate 0.27 over 3. Luckily, everything, the lower bound is, lower limit is 0. So we can make 6 to the third power. Yeah. Minus 9 over 2. 6 to the second power. Plus 106. Okay. The first term, I calculate, this is a 19.44. And second term, minus 162. And third term, we can see easily 600. Yeah. All right. Then, if we calculate, we have 457.44 tons. Yeah. So we had similar with this number, right? So 400 something, right? 430 something, right? That's how I remember. Yeah, very similar. Okay, let's do this one. Write integral that describes the area of shaded region. So shaded, that is the function. So we have 2x minus 104 x squared, right? Now, find the area. So how do we find the area? So two terms, we do one by one. So from 0 to 8, 2x dx minus from 0 to 8, 104 x squared dx. Okay. We'll keep the coefficient x and then add 1 second power over 2. We do evaluate from 0 to 8 minus 104 x to the third over 3. We want to evaluate from 0 to 8. Then we can simplify. We have a squared and lower bound is 0. and negative 1 over 12, right? And 8 to the third power, right? But then they say that exact answer, that means we have to keep as a fraction, right? So let's just simplify. A squared, which is 64. And then 1 over 12, I want to simplify, so I want to make it this way. All right? Okay, so 12. That will be 4 times 3, 8, 4 times 2, then 4 goes with 4, which is 1. We have a 2/3, and the a squared, which is a 64, right? A little bit messy. Okay, so that will be 64 minus 2 times 64, which is 128 over 3. Now, we want to make a fraction answer. So 3, so times 3 over 3, yeah, common denominator. So we have a 64 times 3, which is 192 minus 128. Then we get 64 over 3, which is exact answer. Make sense? So 64 over 3. That's the answer. Okay, let's do last one. All right, so we have this function, and then find the total sales for first week after campaign ends. T equal to 0 to 7. So we want to antiderivative of this function from 0 to 7. And we need to integral term by term, right? So we have a from 0 to 7, negative 30 t to the, no, not yet, t squared dt plus, and 0 to 7, 420t dt. Okay, so when you have coefficient, right, we can write down this way too. It's okay. It's the same. Maybe in that case, you can see easily when you make power rule for antiderivative. Either way, it's okay. So 420, 0 to 7t dt. All right, so we write down negative 30 and antiderivative of t squared, which is t to the third power over 3, yeah? And we want to evaluate from 0 to 7 plus, we write down 420 and antiderivative of t, which is t squared over 2, and then we want to evaluate from 0 to 7. Yeah. Okay, so there will be negative, we simplify, so this is 10, negative 10, so negative 10 t to the third power from 0 to 7. We simplify this 210. So we have a 210 t to the second power from 0 to 7. Okay, so that will be negative 10 and 7 to the third power plus 210, 7 to the second power. So we have negative 10, 343 plus 210, 49. which is negative 3430 plus 10,290. Then that will be 6,860. So let me, using the unit, so dollars per day, we know that, right? So dollars per day and divide by, not divide by, number of days, yeah? So basically days we simplify, so we have dollars, right? We did that last time. So this is dollars. Yeah. Today's the last lesson. I hope you understand. Thank you for watching. Bye.